Hi, everybody. We're going to be taking a look at our first lesson in this new unit on inductive and deductive reasoning. And we start by taking a closer look at inductive reasoning to start with. The objective is to begin to kind of tear apart the idea of using reasoning to make predictions, kind of examining how we reason to do something in order to try and help us have some tools to be able to handle some of the things we do in mathematics. There are two vocabulary words, conjecture and inductive reasoning. Make sure that you're watching for those and that you have written a good description of what they mean by the time the lesson is done. So we started with just a general question, getting you to think about how do investigators determine what happened at an accident scene. So, of course, they have to try to figure out what took place for insurance purposes, and then at another level as well for the criminal level in case something such as impaired driving or reckless driving resulted in someone being seriously hurt, then it becomes at a criminal level. But they're going to be looking for skid marks to show kind of the path of the car. They're going to be looking for the damage on the car. They're going to be asking bystanders. They're going to be looking for mechanical failures or road conditions. They're gathering together all kinds of evidence around the scene so that they can be sure to draw up an idea of what took place. We're going to be doing a similar thing. We'll be examining situations, information, and problems, and our purpose is to develop our reasoning skills. Okay, so to start off with, I want to get your brain thinking a little bit, and I'm going to give you this scenario. And what I want you to do is to pause the video and then try to write these names in order of who came first through to who came last in this particular marathon. And once you're finished, you can take a look at the solutions for it that we have. And these ones kind of take all the information that was embedded in that description and puts things in order so we can see how the runners came in from first to eighth. So the next thing we want to take a look at is and ask, what is a pattern and how do we know when something has a pattern? Well, a pattern is something that repeats itself over and over again. And we know it's a pattern because we're seeing something reoccurring. And it leads us to be able to make a decision that we know what the next thing might be in our pattern. So for instance, a nice easy pattern to start with. Look at it for a few minutes and you realize that it has to do with increasing the number of sides. So from 3 sides to 4, from 4 to 5, and 5 to 6. And so if we think about what will happen next, we'll have a 7-sided figure and then an 8-sided figure. So it would be a septagon followed by an octagon. Take a look at this one for a minute and just stop and consider it. Now what we see happening here is things going up and down. So you have 1 going up and down, and then 1 more time, and then 2, and then 3 up and down, and then 5 up and down. So the question is, what would come next? Well, if we look at it, what seems to be happening is, in order to get the next term, you take the one that you have and add it to the one prior. So there's 1 plus nothing, it's a 1. But then 1 and 2 is a 3, 2 and 3 is a 4, 3 and 5 is an 8, 5 and 8 is a 13, and so on. By the way, we call this something known as the Fibonacci numbers, a very famous sequence of numbers. And we talked about it a little bit in class and talked about some of the interesting things that have happened through the centuries, really, around this sequence. But I would encourage you to stop and Google it sometime. Fibonacci numbers, they're really quite fascinating. This one, again, pause and consider it. And I think what we're looking at here is perfect cubes. This is 1 cubed, 2 cubed, 3 cubed. So now what about patterns? Do they occur in nature as well? Are there things that we can see? Well, some of you said the seasons, the rising of the sun and the setting of the sun, those are definitely patterns that we've come to depend on. And there are other things as well. Look at this close-up model of a sunflower. And you can see the beautiful patterns and symmetry and the beautiful, beautiful stuff. And interestingly enough, when you look at some of these examples closely, you see that their numbers match with the Fibonacci numbers when we talk about rows and so on. That's very interesting to look at. This one is a very unusual, exotic kind of broccoli, actually. And what we're seeing is that this big floret is repeated by the little guy right here. He looks the same as this one close up. And then even the tiniest little guy, like right here, this little nobule, is the same as this when we magnify it, which is the same as that. And then there's the honeycomb, which you can see is a hexagon. And just it's, fascinating. How on earth do these tiny little animals know that this is the most efficient way to store their honey? So, bottom line, observing patterns as we have been doing is an important part of using inductive reasoning to make a conjecture. Let's explore these new words just a little bit and ask, okay, what's a conjecture? A conjecture is a testable expression that is based on available evidence but not yet proven. So we can test it, we can try it out to see if it's true or false, but it's not been proven. It's a conjecture. If you consider this one, and we did this one in class, we're looking at figure 1, figure 2, figure 3. If I made the conjecture, I think figure 10 in this pattern will have 100 triangles, and all these triangles will be congruent to the triangle in figure 1. Stop and consider what I'm saying and see if you can sort out what this means. People saw this in varying ways in order to be able to do it. I think the easiest was when they saw it as a series of perfect squares. 1 squared, 2 squared, which is 4, 3 squared, which is 9, and so on. But when it got to the larger numbers, people had other ways of doing it. For me, I saw that each figure adds one more row underneath the previous one. So this one added this row, which had 3 in it. This one adds this shape and 5 under it. And if you notice, the rows that are being added are 3, 5, 7, 9. It's quite fascinating that we're actually using odd numbers as well. Okay, so here we go to wrap it up. What is inductive reasoning? Inductive reasoning draws a general conclusion by observing patterns around us and identifying properties in specific examples. In other words, if something occurs over and over again, we may conclude that it always happens. This conclusion is called a conjecture. A conjecture, of course, is based on evidence you have gathered. That's why I use this Sherlock clip art to be able to show that. But this is an important fact. More support for a conjecture, in other words, more examples, strengthens it, for sure. But it does not prove it. And that's a really important distinction in mathematics. Okay, so it says use inductive reasoning to make a conjecture about these things, the product of an odd and even integer. Well, if we keep playing with that, it looks like they're always even, or their most are more than 2 digits, etc. Intersecting lines and the angles formed. Well, we've learned a little bit about this one in geometry too. So we're looking at it. We know that the angles all around the intersection add up to 360. We know the opposite angles are equal to one another, and we know the adjacent angles are 180 degrees. So there are a number of things that we've noticed through the years about this. And lastly, what's the difference between perfect squares? Well, if I were to make a list of perfect squares and look at the difference, there's a difference of 3, and then 5, and then 7, and 9. So consecutive odd numbers are the difference between perfect squares. Okay, there you have it. Now, I do believe, this homework assignment has one extra. Take out this 4 because it's no longer in the assignment, and I don't want you to do that. Okay, the rest should be fine. Good luck with your homework, everyone. Have a nice evening.